All right, guys. Hey, Algebra 1. I hope you're doing well with this week's lessons. I hope they're not too complicated, but we're going to continue on with our ratios and rates and, in this case, proportions, which we've dealt with before. And we're going to apply those to what we call scale models. So I think of two scale models that you've used before. You remember when you did like a cell model? Okay, cells are tiny. I mean, we need microscopes just to see them. But when you did your cell model, you didn't draw Miss Auger or make your science teacher this little tiny cell that no one could see. You blew it up. You made it bigger, and you drew the nucleus and the ribosomes, the endoplasmic reticulum. You drew those all, and you try to draw those to scale to make it look like the cell just blown up. And then you've also seen maps where you have a large distance that's condensed into this little diagram, and you have a key to that map that tells you like every inch is 75 miles or 1 centimeter is 100 kilometers. And so those are useful because we can see really small things or really big things in a scaled version of the original form. So here we're really dealing with our maps or drawings of like blueprints and homes and things like that. So the first problem I'll give to you is if I have a scale, and they're going to give you this scale, 2 centimeters is equal to 1 kilometer. So this is dealing with a map, okay? So for every 2 centimeters on that map, so a little distance, it's really representing a whole kilometer. Okay, if this map is to this scale, then it's going to ask you, what does see what they're asking for. Oh yeah, what does 3 centimeters represent? So how much distance does 3 centimeters represent? Okay, so I'm looking for, all right, 3 centimeters. What's that worth in kilometers? Okay, so here's what we're going to do. We're going to realize that there is a map distance being compared with an actual distance, right? There's a map distance, the 2 centimeters, and that's being compared to the actual distance, which is 1 kilometer. And so if I write a rate of that, it'd be 2 centimeters over 1 kilometer, right? Okay, so that's the scale right here, complete. But now they're asking me, well, what if I had 3 centimeters? Okay, how many kilometers is that going to be? So I'm going to represent it with X. Okay, these two, if they are to scale, form a proportion. So really my math problem is 2 over 1 equals 3 over what? So that's what I'm trying to find in this problem. What is that value for X? But it's because I'm comparing the map distances together and the actual distances together. So here, how do you solve a proportion? Well, I hope you remember you cross multiply. So what's 2 times X and what's 3 times 1? Divide both sides by 2 and you end up with X equals, if I simplify that, 1.5. Now please make sure that you get the right unit because I'm not talking about centimeters, I'm talking about kilometers. I'm talking about the actual distance here. So on this map that has this scale, 2 centimeters is 1 kilometer, if I measure 3 centimeters, that's representing 1.5 kilometers. So that's dealing with that map type of problem. Okay, and then they'll give you some actual information. With this next example, it gives us the Rocky Mountain National Park is about 75 miles from Denver. On a map with a scale of 1 inch to 30 miles. So 1 inch to 30 miles. Okay, how far, how much of a map distance is Denver from the Rocky Mountain National Park? Okay, in actuality, it's 75 miles, right? From Denver to the Rocky Mountain National Park, 75 miles. On this map with this scale, how far on the map, so how many inches is Denver from the Rocky Mountain National Park? Okay, so here's my map distance over my actual distance, okay? And that's equivalent to I don't know how many inches over 75 miles, right? We have the map distances up top and the actual on the bottom. You want to keep them proportional. If you get the reciprocal of that second one, for example, you're going to get a wrong answer. It's going to come out with an error. Okay, so here if I'm really dealing with just the numbers, 1 over 30 equals x over 75. That's my actual problem. So I take the weight of the units because I know my answer is going to have inches. Then I'm just going to solve this problem. So 1 times 75 and 30 times x. So 1 times 75, 75. 30 times x is 30x. Okay? So then I'm going to divide both sides by 30. And then I'm gonna get here my work. 75 divided by 30. 30 goes into 75 twice. That's 60. Then I'm gonna go. I'll tell you how far you need to go. In this case, thankfully, 30 goes into 150 5 times. Do not forget the decimal point because that matters a ton. By the way, is 2.5 inches the same thing as 25 inches? No. So my answer is going to be 2.5 inches. So on that map, 2.5 inches is going to represent 75 miles, that distance that we were looking for. Okay, these are proportional to these right here. Okay, so that's basically what you're doing on this lesson. There is one other type of problem they'll get, which I hope isn't too complicated. Basically, we've been looking at just distances, so like how far from one thing to another, but you can also compare like rectangles, like a 4x2 object on a map, is really this 400 by 200 miles in the actual distance. So an example of this problem would be, let's see a good one. Okay, they're going to give you a scale of 7 centimeters. For example, 7 centimeters is representing 2 meters. Okay, so this is the map, or the blueprint in this case, and that's the actual. So just a reminder, a meter is a little over a yard. So like a yard, that's about a meter. And so 7 centimeters, so just a little bit right here, is going to represent 2 yards, basically. Okay, then they say, what are the actual dimensions of a room that is drawn 17.5 centimeters by 14 centimeters? Okay, now please don't get this confused. This is what you're going to have to do. It's the same thing as you did on the last problem, except you're doing it twice. You're going to have to convert this measurement into meters and this measurement into meters, so you're doing it 2 times. So first I'm going to use this this map or this blueprint over the actual, and I'm going to do it with the first measurement right here. So the 17.5 centimeters up top, and I don't know how many. Okay. And the meters down low. I almost mixed it up myself. I almost started flipping it with that. Okay, so I'm going to find how many meters is that 17.5. So really I'm dealing with 7 over 2 equals 17.5 over x. That's what I'm going to work out right now. So cross multiplying, 17.5 times 2. So 14, 15, 3. So 35 there. 35 equals 7x, which is very nice. I divide both sides by 7, I get 5. So 5 meters, that's my first answer. That room in actuality is 5 meters long, and that's the first conversion. Then I have to do it again with this second conversion, so I'm going to do the same process, except this time with the second measurement. And this one's going to be 7 centimeters over 2 meters equals, so using that scale again, 14 centimeters over x meters. So I'm trying to convert the second dimension into meters. So really I'm dealing with 7 over 2 equals 14 over x. So I'm going to cross multiply like I did before. 7 times x, 2 times 14, divide both sides by 7, and I get 4 meters. So that room in actuality is 5 meters by 4 meters, which in the blueprint is 17.5 centimeters by 14 centimeters. That's the actual size, the actual dimensions of that room. So you just had to do it twice, okay? There is a tricky problem, the last one I'll give to you. It's a thinking problem. We didn't go through it exactly, but I gave you everything you needed to know. You just need to think through that process of finding out whether that entertainment center will fit or not. So please think that through. But the other one should be straightforward. Now, you're going to get decimals that could continue on forever, but I want you to round to the nearest tenth. So don't go all the way out into the hundreds, thousands. Just round to the tenth, okay? And that'll keep you sane in these problems. Just a reminder, guys, we're going to get into trig ratios. So if you haven't gotten a calculator or access to one, please try to get that done soon. Tomorrow's lesson, I would be okay with you using a calculator. You don't have to, and I don't say you must at all, but definitely after that, we're going to have to start using some calculators to help us out, and we'll get into those trig ratios, which really you need the calculator to make those problems a lot easier. Okay, your homework, therefore, after all this talking, and a reminder about your calculators on this lesson is going to be 2 through 12 even. So numbers 2 through 12 even, and that's found on pages 279 to 280, 279 to 280. So you have a few problems for today. We will have an optional Zoom meeting, so if you have any questions, you can come to that. It's a drop-in, drop-out, so you don't feel like you have to go in there. You either have to go into it at all or go into it the whole time. Just drop in, Mr. I have a question on number 4, and then when you get your answer, you can just drop out of it. Okay, I hope you have a good day, guys, and I hope this lesson was a little bit clear, at least enough to help you, especially with that last problem that I want you to think through. All right, take care, guys.